This time we're going to do the opposite of our last lesson, and instead of going from ratios to rates, we're going to go from rates to ratios. First, I want you guys to write the following ratios as rates. So if I said that the ratio of miles to hours, let's say, is 434 to 7, how would you write this as a rate? Well, remember our key to finding the rate is to make the unit 1. And so in this case, to do that, let's divide both sides by 7 so that we'll have 1 unit on the right of this ratio. Sure enough, if we do that, both of those sides divided into 7 groups will give us 62 miles per hour. Okay, now your turn. Take this ratio, 5 laps to 4 minutes, and turn it into a rate. So the ratio was 5 to 4, which was our laps to minutes. But to find out what the rate would be with a unit of 1, we would have to divide both sides by 4. Well, I know 4 divided by 4 is 1. That would give us 1 minute. But what is 5 divided by 4? Well, isn't it 5/4? So we are free to say 5/4 of a lap per 1 minute is the rate. I want you to take a moment, look at this model, and see if you can plug in our ratio of 5 to 4 for the ratio, the unit rate, and the rate. Okay, here was that model. Let's start with the ratio. Remember, we had 5 to 4. And that's our ratio, 5 to 4. But what about our unit rate? Well, earlier we found that it was 5/4 because we divided both sides of the ratio by 4, making sure that we had 1 unit. 5/4 is our unit rate. What about our rate? Our rate is the same thing. It's that 5/4, except we need to write it as a ratio. 5/4 laps to every minute. What if I gave you this model and I only gave you one component? Can you tell me what the unit rate and the ratio is of 6 feet to every second? Well, the ratio is the easiest one. That'd be 6 to 1. 6 feet to 1 second. And because the unit rate is simply the value of the ratio for every 1 unit, we can look at our ratio and see, oh, it's 6 for every 1 unit. The value, or the unit rate, is 6. So Dave, the pool cleaning guy, cleans pools at a consistent rate. What's his rate? 3/5 of a pool is cleaned every hour. What's the ratio of the number of pools to the number of hours? If we remember our data of Dave cleaning the pools at 3/5 of a pool for every hour, and we want to know what the ratio is, well, we're going to have to do the opposite of what we did before. And instead of dividing, we're going to multiply both sides by 5 so that I can get a whole number on the left side and the right side of our ratio. So 3/5 multiplied by 5 will give us 3 whole, and that 1 hour multiplied by 5 will give us 5 whole. Or another way to say this is that the ratio of pools to hours is 3 to 5. Because remember, we multiplied 3/5 by 5, and to make it equivalent, we had to multiply the other side by 5, giving us 3 to 5. Well, how many pools then can Dave clean in 10 hours? Okay, so we know that for every 1 hour, Dave cleans 3/5 of a pool. But not only that, but we also know that 3 pools he can clean in 5 hours. So how about 10 hours? Well, how can we go from 5 hours to 10 hours? Yeah, let's multiply by 2, right? We just need double that amount of time. And of course, to make equivalent fractions or equivalent ratios, we must do the same to both. And so in the end, making 5 hours 10 hours is also going to make those 3 pools 6 pools. And so Dave can clean 6 pools in 10 hours. How long does it take Dave to clean 15 pools? So if Dave can clean 3 pools for every 5 hours, and we're asked to find out how much time it would take for 15 pools, how do we go from 3 pools to 15 pools? Yes, we need 5 groups of those 3 to make 15. And if we're going to have 5 groups of the pools, we need 5 groups of our hours. And that's going to tell us that 15 pools is going to take Dave 25 hours. Dave can clean 25 pools in 15 hours, we can write. You know, we can also do this many other ways. Let's try a tape diagram. So here's my 3 pools and my 5 hours that Dave takes to clean them. If I wanted to know how many pools he would clean in 10 hours, I would simply plug in 2 for every one of my units of hours, because that would give me 10. And since I know that my units are 2, I can plug those 2 units in for my pools and see that 2 plus 2 plus 2 is 6. 6 pools every 10 hours. But remember, the beauty of tape diagrams is we can plug whatever value we want to in these units. So, if we're asked to find how long it would take for 15 pools like we were, then we would say, well, our pools equals 15 hours. And we take that 15 and dump it equally into all of our units, which are 3. And 15 dumped into 3 units would be 5 each. And that tells us how much each unit is worth. And so we can see that it's 5 groups of 5 for Dave's amount of time to clean 15 pools. Or 15 pools takes him 25 hours. Okay, now, Emmeline. She can type at a consistent rate of 1/4 of a page every minute. What's the ratio of the number of pages to her number of minutes? If she types 1/4 of a page for every 1 minute, then we know that we can multiply 1/4 by what? 4. And that will give us 1 unit. But if we multiply 1/4 by 4, we also need to multiply the number of minutes by 4, and that would give us 4 minutes. All this to say that 1/4 of a page every 1 minute is equivalent to 1 page every 4 minutes. So, Emmeline, she has to type this 5-page article, and she only has 15 minutes until her time is up. Will she make it? I mean, the ratio she has to be equivalent to is 5 pages for every 18 minutes. Can she do that? Well, let's find out what her unit rate is. Let's divide both sides by something that will give us 1. Well, 5 divided by 5 is 1. So let's do that. And if we do that, we have to divide 18 minutes by 5 as well. Ugh, but this is kind of tricky. We could say that it's 1 to 18/5, but that's not very helpful. So let's use something else. Let's use a double number line. Remember this guy? Well, because we are dealing with pages and minutes, we can label both of our number lines. And because we've already learned that it takes her 4 minutes to do 1 page, we can start with 1 page at 4 minutes. And so to find out how much time it would take for 2 pages, we would just double what we already have, right? 1 page doubled is 2, and 4 minutes doubled is 8. And we continue this pattern, we'll see that if we want to find how much 3 pages would be, we would just triple the amount of pages, which means we would triple the amount of minutes, and quadruple, and so on and so forth. But remember the question? We wanted to know if she can type at a rate of 5 pages for every 18 minutes. Well, here's the 5 pages. So, how long does it take her to type 5 pages? Aha! It takes her 20 minutes to type 5 pages. And 18 minutes was where she needed to be able to type 5 pages. And 18 minutes is somewhere between 16 and 20. In fact, it would be halfway between 16 minutes and 20 minutes. And 18, we can see, corresponds to exactly halfway between 4 pages and 5 pages, which would be 4.5. So she can't type at a rate of 5 pages for every 18 minutes. She can only type 4.5 pages every 18 minutes. Okay, so poor Emmeline. Now she has this 7-page article to type. How long is it going to take her? 7 pages. Okay, let's use our trusty double number line again. We got pages to minutes, and we know that for every 5 minutes, because of our last problem, it takes her 20 minutes. How could we find out how long it would take her to do the next value, 6 pages or 7 pages? Well, if you remember, the way that we figured out all of the amounts of times per pages was that we multiplied the number of pages times 4. Because our original ratio was 1 page to every 4 minutes. And remember, we would double the 4 and triple the 4 and so on. So if I want to know how many minutes it will take for a 6-page article, I'll simply multiply 6 times 4, and I'll get 24. It takes her 24 minutes to type a 6-page paper. But we want to have Emmeline type up a 7-page article. How long will that take? Following this pattern, 7 times 4 will give us 28. 7 pages will take Emmeline 28 minutes. And we write it out something like this. It will take Emmeline 28 minutes to type a 7-page article. Xavier, he's a swimmer. He swims at a constant speed of 5/3 of a meter for every second. What's the ratio of the number of meters to the number of seconds? Well, because we know that 5/3 of a meter to every second is his ratio, then we can multiply 5/3 by, what to make it a whole? We'd multiply it by 3. 5/3 times 3 will give us 5, and we will multiply our seconds by 3 as well, and we come up with a ratio of 5 to 3. 5 meters for every 3 seconds. Xavier's so good, though. He's trying to qualify for a national swim meet. In order to qualify for this meet, he must complete 100 meters in 55 seconds. Is he going to be able to do that? Why? Or why not? Let's try a table this time to see if he'll qualify. Well, the two quantities that we're comparing are meters and seconds, so we can label that. And we remember the data from the beginning, which said that Xavier can swim at a rate of 5/3 of a meter per second. But we also found that to be 5 meters for every 3 seconds. And so let's plug that in. 5 meters for every 3 seconds. But Xavier needs to swim more than 5 meters. He needs to swim 100 meters, and we want to find out if he can do it in 55 seconds. So let's make small increments. What about if we jumped from 5 meters to 10 meters? What would we do for our seconds? Well, to go from 5 to 10, we would have to double the 5, right? 5 times 2 is 10. And so if we're doubling our meters, we're also doubling our seconds. 3 times 2 is 6. So Xavier swims 10 meters every 6 seconds. But we still got to find what his speed is for 100 meters. How would we do that? 100 meters. How many seconds is he going to take to do that? Yes, you probably recognize now that to go from 10 meters to 100 meters means we would have 10 times as much, right? 10 times 10 is 100. And so 6, we'd have to have 10 times as much as that. 6 seconds, 10 times more, is 60. Xavier would swim 100 meters in 60 seconds. And the question of, will he qualify at a rate of 100 meters in 55 seconds, is answered with the answer that no, Xavier will not qualify for the meet because he can only do 100 meters in 60 seconds, which is not fast enough. Okay, Xavier's a little down, but he's wondering if he can qualify for the same meet for 200 meters. To qualify for the 200 meter race, he would have to complete those 200 meters in 130 seconds. Will he be able to qualify for this event or not? Okay, let's start with the data we know. We were told that he swims 5/3 of a meter every 1 second, which we calculated to be 5 meters for every 3 seconds. Let's use a table again. We have meters and we have seconds, and we know that at 100 meters, according to our last problem, he swims 60 seconds to complete those 100 meters. Well, what about 200 meters? Let's think about this. How do we go from 100 meters to 200 meters? Hey, it's double the amount, isn't it? And if the meters are doubled, then we'll have to double the seconds as well to have an equivalent ratio. And we see that for 200 meters, he swims 120 seconds. So, if they're saying that he must swim those 200 meters in 130 seconds, will he be able to qualify? Yeah! Xavier will qualify for this meet because he would be able to complete those 200 meters in 120 seconds. Okay, so what have we learned today? We've learned that if we have a rate of a fraction, like 2/3 of a gallon to every 1 minute, then it corresponds to a unit rate of 2/3, which is also equivalent to a ratio of 2 to 3. Not only that, but we learned that all ratios associated with some rate are equivalent because they always have the same value. Whether we were dealing with 1 or 100 of them, we had equivalent ratios.